To mastering C pointers. In this video series, we will go step by step from beginner to advanced pointer concepts. So by the end, you will feel completely comfortable using pointers. You will also learn how to use advanced pointer techniques to write more efficient code and design better programs. This course has been divided into 5 modules. Before we dive into pointers, we need to understand how memory works and how program variables are stored in the memory. In module 1, you will learn more about memory addresses and program memory layout. Think of this as a building foundation for everything else. Module 2 will provide introduction to pointer. In this module, you will learn what pointers are and how to use them, and even will do some arithmetic with them. This module is all about using pointers with arrays, function, and dynamic memory. These are the tools that make your program more powerful and flexible. In module 4, we will use pointers to work with structures, create linked list, and explore multi-level pointers. You will see how pointers unlock ability to manage complex data. And finally, in module 5, we will wrap up by tackling pointer mistakes like null pointers, dangling pointers. Plus, you will learn the best practices for writing safe, efficient, and bug-free code. Welcome to module 1 of this course. In this module, we will lay groundwork for understanding pointers by exploring the fundamental concepts of memory, variables, and addresses. These topics will help you to grasp how data is stored and addressed in C and will provide a strong foundation for upcoming sessions. Let's begin by understanding memory and variables. In context of programming and pointers, when we say memory, we are referring to RAM, that is random access memory. RAM is used to store the temporary program data while it is running. RAM is divided into different locations and each location has a unique address. In this case, let's say RAM starts with 0th address and it grows till n. Now let's consider this declaration int I equals to 10. What does this declaration tell compiler to do? When compiler encounters this declaration, it will reserve the memory space to hold the integer value. Let's say it reserves the address 1000 to hold this integer value. Then it will associate the label I name with this location I, and it will store the value 10 at this location. So we can represent the i's location in memory like this. When you declare a variable in C, the compiler assigns it a specific location. Variable's name act as a reference to that. Let's understand this with the help of code. Here I have declared one variable int I equals to 10. Let's print the value of I using this line. How do we get the address of I? We use the ampersand operator, which is called address of operator, to get the address of any variable. So ampersand I will give the address of I. Let's run this code. Here the value of I is 10 and ampersand I gives the address, which happens to be this address in our case. Now let's understand memory layout of a program. It is essential to understand memory layout of a program to mastering pointers because it helps us to see where variables and data are stored while program is running. Memory layout of a C program is broadly divided into these segments: a text segment, data segment, BSS segment, heap segment, and stack segment. Let's understand the use of these segments with the help of one simple program. Let's begin with main function, int main. When we compile the compiled program code goes into text segment. Text segment contains the machine code, and that's why it's read only. Let's declare one local variable int I. Local variables go into stack segment. Let's declare one global variable, say int j equals to 10. Global initialized variables go into data segment. Let's declare one variable, say int a. Uninitialized global variables go into BSS segment, and the memory allocated using malloc, calloc, and related dynamic allocation techniques goes into heap segment. Now let's summarize. Text segments hold the machine code. Data segment holds the initialized and static variables. BSS segment holds uninitialized variables. Heap manages dynamically allocated memory. And stack stores local variables and function calls. In the next session, we will build on this foundation by learning more about what pointers are and how to use them. Thank you for watching and see you in the next session.